In this video, we're going to learn about Avogadro's law. Now, Avogadro's law states that if you have a sample of gas that occupies a certain volume and you were to increase the amount of gas, well, then its volume would proportionally increase. Or if you were to take away some of that gas, its volume would proportionally decrease. But essentially, the volume of a gas and the amount of gas are directly proportional. This might be fairly intuitive, but an interesting implication of Avogadro's law is that it doesn't actually matter what the identity of the gas is, whether it's hydrogen, oxygen, or anything else. Always, when we're talking about amount of gas, it's just number of particles or moles. So if you have samples of hydrogen, nitrogen, and oxygen, and they all occupy exactly the same volume under the same pressure and temperature, then it means that they all have the same number of moles or molecules in them. Now, let's actually see all this at play in a simulation. So we have 60 molecules in a container, and the volume of the gas is approximately 0.40 whatever units of volume. The piston is pushing back with some pressure, the molecules are pushing out with the same, and we have this equilibrium where the volume is pretty much constant. Well, according to Avogadro's law, if I were to take the 60 molecules and I were to double them, well, the gas volume should approximately double, and we are seeing an increase in volume from about 0.40 to eventually it's going to hit 0.80 approximately, if the simulation gets it right. But it also could take a little while. In any case, Avogadro's law, it's all about volume and number of particles, but as you might imagine, there's also a relationship between number of particles and pressure. And actually, I'm going to focus on the pressure first. So the relationship between particle number and pressure at constant volume is that there's a directly proportional relationship. So as you get more particles, pressure will increase if the volume is held constant. And this just means if you have more particles, you're going to get more frequent collisions between the particles in the container. Imagine if all of these particles were held in a volume much smaller than that. You just have much more frequent collisions, and there would be an exertion of greater pressure. Now, when you have a flexible container, and this is what Avogadro's law is about, it's a relationship between volume and number of particles. And that's why you can see it in the simulation. But if you have a flexible container, you'll also see that there's a directly proportional relationship between the number of gas particles and the volume. As we saw, the gas volume did increase, and note it's pretty close to 0.80 as predicted. Since we've doubled the number of molecules, we're about doubling the volume. So we see a directly proportional relationship between number of particles and the volume that they occupy. And this is just a result of the fact that the particles are spreading out. They're spreading out to exert maybe more force, but over a greater surface area. And as a result, the pressure remains constant as the volume increases with the number of particles. So that's Avogadro's law, and I hope this video has been helpful. Feel free to leave any questions or comments in the comment section below. Thanks for watching.